Hey everyone, welcome back to another Minecraft Explains video. Today we're going to be talking about planetary boundaries. The last three of planetary boundaries, arguably the most difficult to talk about in
I'm
Minecraft.
getting a phone call.
Oh, great. That's a great introduction.
Sorry.
Thanks.
Okay, can I just get this?
Yeah, go for it.
Okay.
Mute yourself. Actually, you know what? I feel like I want to keep that first intro in. But what we were saying was this will probably be the most difficult planetary boundaries to talk about because we're talking about the atmosphere. And the planetary boundaries are ozone depletion, or stratospheric ozone depletion more specifically, aerosol loading, and novel entities. And they are all like invisible to naked eye, so it's very difficult for us or anyone to visualize it. But yeah, we'll just rock and roll.
Let's rock and roll.
Let's just jump straight in. Okay,
Yeah.
boom. This is our attempt in explaining what the ozone is, what the issue is, and why it's an issue. So do you want to explain why there are a bunch of wool over here?
Yes. So the wool, basically, the different layers of like different coloured wool is different levels of the atmosphere. Can you say the whole thing is the atmosphere?
Yeah.
Okay. So and then they like the distances determine like which level of atmosphere it is.
It's not actually true scale, just saying. Like the ionosphere technically is just the ions that are trapped like all the way from, I don't know, stratosphere up, and thermosphere is actually massive. But I made the stratosphere big, so it's to visualize that, you know.
Yeah.
Ozone is actually in the stratosphere, not in some other random spheres. But yeah, not to scale, don't take it seriously. But anyway, ozone is in this level, stratosphere, which is why it's called stratospheric ozone, and it is the biggest effect on the ozone depletion is actually over Australia and Antarctica and the South Poles. It's there because of this chemical that we're all using. It's called the CFCs, and it basically erodes what is the ozone cycle. And this is my very brief diagram of the ozone cycle. Let's say these yellow like rays are UV radiation, and each quartz set is like a oxygen atom, and ozone is made of O3, so oxygen times 3, and that's like their bond. So with radiation, it breaks this down because it's unstable, and it separates it to ozone. The ozone separates to oxygen and an oxygen like atom, to O2 and O. But it's also reversible, so if you use radiation, UV radiation to this, it will also form back to O3, which is why there's like a good balance. It's a cycle, everyone is happy. But CFCs, which is also short for chlorofluorocarbons. That is a mouthful.
Chlorofluorocarbons.
You see my point? Okay. Why did they invent that? Okay, whatever. They basically speeds this erosion up because they would just attach themselves to this one oxygen molecule. So let's say I represent, I have stone. So they basically just attach themselves with this oxygen molecule, and it's more stable than O3 or O2 and O. So it's less likely to break down. And it does break down sometimes, but it's a lot slower. Like breaking down is a lot slower than O3. So if it wasn't clear just now, yeah, stone basically represents CFCs, and it yoinks one oxygen atom, and so this poor O2 has no oxygen atom to be friends with to become O3. So that's like a depletion of ozone. And also, I think one thing that we forgot to say is ozone is important. Stratospheric ozone, not tropospheric ozone. Stratospheric ozone is important because it kind of acts as like a blanket on top of our atmosphere to prevent really harmful UV rays from coming through. Basically, the effects of a depleted ozone layer on the stratosphere is a bit like losing cloud cover on a really hot day. The fire here represents just like the heating up of the area. So, increased temperatures, increase like forest fires. People sweat a lot and then die from dehydration. It gets hot. Okay, it gets really hot, and it's dangerous as well, like dangerously hot, because it's a different type of heat. It's a different type of UV as well. UVB and UVC rays, which is a lot more dangerous than the current rays that most people experience.
So because it's getting a lot hotter, ice melts more, and especially because the ozone depleted in the pole areas specifically. So loads of ice was lost, which means we also have a lower albedo effect, which is basically because ice has a really bright color. It reflects the sun, so it has a cooling effect. But when we lose ice, the ice is replaced with dark ocean, which absorbs the heat. So it just increases warming, which then increases ice melting. So it's like just like a positive feedback loop where it's just getting hotter and hotter and meltier and meltier. So not good.
Yeah. But also to clarify, with albedo, it's the lighter the color is. So rather than like brighter, I think you said brighter.
Yeah.
Yeah. So like a really high albedo will be like
light.
Yeah, like snow. I was thinking like white colors, and ice is like lighter in color, in comparison to like the deep dark ocean. So that's what hippo meant. But yeah. The effects on plants is that a lot of the current, well, not just plants and animals, but just like our ecosystem in general, we are used to the current rates of UV, and erasing that ozone layer and allowing a really powerful UV to hit the earth and our ecosystem, we don't have the time to adapt to that change. But also like the current like animals that we have are very sensitive to light anyway, especially like plants, like certain plants and like phytoplanktons, and it just kind of will affect the whole ecosystem in general. Food chains will be affected. Can cause skin cancer for mammals. But yeah, this is the basic rundown of ozone depletion. Right, aerosol loading, it's basically the increase of aerosols in our atmosphere.
But what is an aerosol?
Yeah. Oh, yeah. Good question.
Thank you.
Wonder why you asked. So aerosols are basically any really small particulate matter, like really, really, really small particulate matter in solid or liquid form. A few examples of aerosols is like, smoke, pollen, salt, volatile organic compounds, or like toxic metals that are broken down to like microscopic sizes, but obviously still potentially dangerous to like if like to humans if inhaled. So they normally come from, well, they can come from both natural and man-made sources.
So natural sources are things like volcanoes, eruptions, so they give off like loads of ash when they erupt and stuff. And also things like natural forest fires, or like wind picking up dust or pollen and like distributing it into the air.
Yeah. And also, yeah, aerosols are just anything tiny. It doesn't necessarily have to be like a chemical or like a man-made thing. But it's just anything that's small. Man-made sources can be like factories, or when they burn coal and fossil fuels, like combustions and all that stuff. It can release stuff like sulfur. Yeah, also like cars and stuff like that. It can also release carbon. Some of them are microscopic, some of them are not. Some of them you can see, like dust. But yeah. So there are many impacts on both humans and animals and our ecosystem. But the most important is like air pollution, visible air pollution, or like sensory air pollution, like stuff that you can smell. Yeah, just it kind of some impacts on like humans can be like asthma, allergies, respiratory issues and stuff like that, or like more long-term diseases or cause cancer even. Yeah, actually some models argue that air pollution causes more deaths than HIV or AIDS, which was surprising.
That's crazy.
Yeah, I'm like, wow. And it's like a lot of the current air pollution is from like man-made sources, and they're causing death. Like imagine the guilt, like do something and you're like, oh my gosh, I might have just killed someone. The other effects are like, let's say
Acid rain.
Yeah, acid rain, and also like indirectly climate change. But yeah, acid rain damaging for plants, mostly plants to be fair, because of the sulfur and nitrogen, like increased nitrogen as well. But that's just air pollution rather than aerosol loading. But yeah, indirectly climate change is a bit like affecting rainfall, cloud patterns, water patterns, like just the water cycle. Yeah. Moving on to the last point.
Novel entities. Basically, novel entities are like man-made chemicals, and they're specifically like new chemicals that we have introduced as humans to the planet. So, for example, we have like pathogens and diseases, plastics and like microplastics and things, or radioactive chemicals and radiation.
Yep.
So well, these are all things.
Some examples. There are definitely more.
Yeah. Oh yeah, there are loads. I would say most things.
Like chemical pollutions. Basically, just elements that are introduced by humans to humans negatively affecting humans. In the long run. In the long run. Here are some important like terminologies or just things to know, especially for microplastic, is biomagnification and bioaccumulation. So basically, one of the effects of microplastics to our ecosystem and atmosphere is biomagnification. And that's because when animals ingest plastic, it just stays in our stomach, or it stays in our system. And when another animal eats said animal, then it just gets transferred to the second animal. So bioaccumulation is basically just the idea that chemicals, plastics, stuff like that, they stay, once they're in a food chain, they stay in the food chain and accumulate throughout the entire food chain. But biomagnification, plays with the idea that one animal eats multiple food sources that is contaminated. So here's an example of a food chain. Let's say zooplankton is at the bottom, and well, technically it's phytoplankton, but yeah. Anyway, zooplankton. Let's say they have 0.1 unit of chemicals or novel entity of a novel entity, and sardines eat zooplanktons for dinner, and with that they got 2 units of not of microplastic or something. And then tuna eats a bunch of sardines for breakfast the morning after, and then it just magnifies to multiple because there are multiple sardines with a concentration of microplastic. And then you get to humans. This is actually, it should be a lot bigger number, but this is just an example. But yeah, apex predators, we get we get the most hit because all of the other chemicals has been in the cycle already until it gets to us. So it's not like we have a choice in that sense of choosing how many chemicals we're ingesting from the animal before.
Yeah.
But yeah, this is a basic explanation of biomagnification, especially on microplastics and stuff. Yeah.
It does show how hard it is to stop biocommunication and biomagnification, because you literally have to stop it at every single stage of the food chain. And because novel entities, I don't know, they're usually things that stick around, and they're difficult to clean up.
Yep.
So for example, plastics.
Also
it's
radioactive.
impossible. Yeah. It's impossible to get rid of all the plastic in the ocean. We're never going to be able to do that because, well, you can't. Number one, you can't pick up microplastic. That's really difficult. And then the ocean is just so big, we can't.
Yeah.
Do that. So it's basically impossible.
Yeah.
To fix. Once we've done it, which we have, that's it. We're screwed.
Yeah. Well, it's also quite similar with the effect of radioactive chemicals.
Yeah.
Because once an animal has been in contact with radiation, it mutates, and that then affects the food chain, but also that mainly affects the food chain. Actually.
Yeah.
The food web, not just a chain, it's a web.
Ooh, the web.
But yeah, on the topic of radioactive chemicals, actually, there are a lot of the more human issues, I want to argue, that are more widely known, stuff like skin cancer, organs being weird, and changing DNA and scary stuff like that. And yeah, it's just not a good idea to be prolonged. I mean, I get why radioactive chemicals are so important, because they actually they just give a lot of energy, and they're really important materials. But then again,
and when you have an X-ray or something.
Yeah, exactly. Exactly. Yeah. It is important to a lot of things, and we have benefits from it. But at the same time, we have to be careful of the consequences.
Yeah, we just got to do things responsibly.
Yeah.
That's all we ask, world, please.
The last example that I think we should draw is pathogens and diseases, because this relates to us a lot with the current pandemic. So we want to represent a silverfish as COVID. Pathogens are considered a novel entity because it's introduced by humans from the wildlife to human life. From natural ecosystem that into like very, what's the word, congested cities where it can mutate and just spread like wildfire. At the end of the day, knowing about all these global issues is important, but like what's more important is what we can do about these global issues. And I think for most part it starts with us, the individuals. But
yeah, I know. I've been thinking a lot lately about whether it, like individual action and collective action and stuff. But I think individual action is really important, even though it is kind of often slated like, oh, we shouldn't be, like, it's not up to individuals. But I don't know, I think to quite a big extent it is. I think we need to show that we want change, and like, I don't know, I think small things can make a big difference, especially when we're talking about things like pollution. And specifically these three boundaries, I feel like individual changes can be really effective.
I think also it's more of like looking at the little things. Like it's easy for us to just like change our lifestyle like a little bit. And if everyone in the world changes, like, or is like, I don't know, maybe not change, but like it's just a little bit more conscious about their energy expenditure, the amount of time they go outside, or like the amount of food or the amount of meat they eat specifically. Like just minute changes make a big difference. Like it's more of like the individual and the collective working together. Like everyone in the collective is working little things in their lifestyle that can be very easy like to change. Little things make a massive difference if everyone does the little thing, rather than like having one person make a massive change in their life and it having like a little effect.
And like it's not necessarily like you can do it for selfish reasons. Like this is like what the effects and the impacts that we talked about, like a lot of them were like health impacts, not just on like the individual but like for society as well. Like these things, it's all these three things go out into the world and like affect everybody. It's not just like a closed thing where, oh, your action only affects yourself, so then you can do whatever you want. Like, no, your action actually affects everybody, all the animals, all the plants, like future generations. So like, I don't know, I think we just need to like realize how impactful we are in our everyday lives.
But also I think the most important thing like ever in regards to sustainability in general is just continuing the discussion and just being able to, you know, like make small minute changes, but just let others know as well that they can also make a difference. And because people are generally empathetic people and have feelings, and so just engaging with that is very important, because we don't really have that much power on like how companies run except to speak out. Like we can't like, go like march into someone's office and say like, I mean that's even speaking out, but like we can't like physically change how companies do their work, except the only thing we can do is to tell them to stop doing what they're doing and find more sustainable alternatives. I feel like it's so simple, a lot of these things. I mean, obviously it's so complex. Like, I'm not saying it's simple. But
I feel like what you're trying to say is like, we can't make them change. So like, we're just going to have to stop. Like, we're just going to have to like change to a company that does it differently, or, you know, that, like it's so, we're so stuck in old habits.
I think it's less of that, but more just like, it's so simple to advertise for climate change, and it's so simple to just be more conscious. And just the idea of being more conscious is helpful to
Mhm.
the world we're living in. And it's so basic. Even though, like, obviously, the whole concept of it is very complicated. And the extent of how we're damaging is very complicated. But, like, once we start breaking down to what we can do and just be more conscious and aware of what we are doing, that makes the biggest impact. Thanks, guys, for watching. And this will be the last Planetary Boundary video because we've done all of them already. Whoop, 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 whoop. But yeah,
We did it.
this one was a lot more difficult.
Yeah, this one is the hardest.
Yeah. Anyway, we digress. Have a good day, all of you guys. I hope you guys are more sustainable today, tomorrow, than today. Just I'm digressing. My brain is being all weird and fuzzy and mush. Anyway, bye. Sight.